Hello, welcome back. Today's lesson is lesson 3.2. It's titled All Things Being Equal. And today we're going to learn about solving equations. This can be found on page 295 of your textbook. Little comic here you've probably seen on Facebook or some other social media. Towards the middle of the page, they start the classwork, and that's what we're going to be doing today. They want us to consider the following four statements. New York City is the capital of Guatemala. Over 1 million distinct species of animals have been cataloged and named. 8 equals 5. 13 minus 10 equals 3. Well, obviously the first and third statements are false, and the second and fourth statements are true. So they're stating that something's equal, whether in words or whether with symbols, our equal sign, they're stating that something is equal. So they start us right into a purple box. An equation is simply a statement that two quantities are equal. Like verbal sentences, the equation can be true or false. So number one gives us a statement, and they're asking, is it always true or always false? The number of hours you'll spend on homework this week is 14. Well, that can sometimes be true, sometimes be false. So we'll say sometimes either. Sometimes true, sometimes false. If I do indeed spend 14 hours studying, then it's a true statement. If I'm on break and don't have any homework and I'll spend 0 hours studying, then it's a false statement. So it can be true or false depending on what I actually do that week. At the top of page 296, they define a conditional equation. An equation written to represent a statement is considered a conditional equation, and this is the type we most commonly use in math and other areas, and we use algebra to solve these. If we use the letter H to represent the number of hours we spend on homework, we can write our equation as H equals 14. So the only solution that works is 14. And I know that sounds obvious, but we'll get into equations where it's not quite as obvious. So we're right into another purple box. What it means to be a solution. So part one says, a number that makes an equation a true statement when substituted in for the variables is called a solution of the equation. Number two says, the set of all numbers that make the equation true is called the solution of the equation. Like we said, with H equals 14, the solution's pretty obvious. It's 14. But what about when they give you something like the next one, negative 12y plus 17 equals 2y minus 11? It's not so obvious in that one. So we need to come up with a process, build a toolbox for solving equations. Another purple box, the process of solving equations. When changing the form of an equation in an attempt to find the solution, anything you do to the equation should not affect whether it's true or false. So we want the truth or falseness of the equation to stay the same. So they give me a really obvious equation. 5 equals 5 is a true sentence. 5 equals 10 is a false sentence. So let's look at what happens here. If I multiply both sides by 2, the first one becomes 10 equals 10. Cool, still true. If I multiply this one, each side by 2, I get 10 equals 20. So it's still false. So what that tells me is that if I multiply both sides of an equation by a number, it doesn't change the truth value of the equation. A couple more they're going to have us experiment with and play with and see what we can get. In number 3, we know that the equation 1 foot equals 12 inches is a true statement. So it's also true that 3 feet equals 36 inches. I'm just multiplying both by 3. And that's how they're getting that. So we can multiply both sides of the equation by the same thing and get a true sentence. In number 4, it says the equation 1 mile equals 55,280 feet is true, while the equation 1 yard equals 1 meter is false. What happens if we multiply both sides of the equation by 0? Oh, we may have found a trick in our solution. So we've just said we can multiply both sides of an equation by the same thing and it doesn't change the value. Well, let's go through and multiply the first equation times 0. And that gives me 0 equals 0. Okay, so far so good. That's still a true statement. Uh-oh. What happens when we multiply the false statement on both sides by 0? I get 0 equals 0. I've gone from a false statement to a true statement, and that's a problem. So what that tells us is I can multiply both sides of the equation by anything except 0. So we caught a catch. So we can multiply both sides by anything except 0. And there it is given to us on the top of page 297 as our first tool in our toolbox. We can multiply both sides of an equation by the same number or expression as long as it's not equal to 0. Same is true for division. So the multiplication division rules are almost the same. I can divide both sides of an equation by the same number as long as it isn't 0, and it won't affect the truth value. The other two we're going to add into our toolbox are addition and subtraction. We can add the same number on both sides of an equation, and it keeps the truth or the false value of it. Same thing with subtracting. So that's all we're going to have in our toolbox. We're going to multiply, divide, add, and subtract. And your goal in solving an equation is to get the variable alone, undo whatever's been done to it. So we're looking for opposites here. If I want to undo addition, I'm going to subtract. If I want to undo multiply, I'm going to divide. So that's going to be our goal throughout any solving equation. And in this course, all we're going to undo is addition, subtraction, multiplication, division. You could take that and expand it into higher levels and do undoing more things, but we won't in here. So they have a nice little solved example for us with 4 parts. The first one was d divided by 360 equals 0.35. What is the opposite of division? The opposite of division is multiply. So they've multiplied both sides by 360, leaving them an answer of 126. And then I love that they're checking here. This is an important step. You can always check your answer by plugging it back in. In part B, we had 5t equals 60. It's important to recognize that when 5 is smashed up against that t with no signs between it, it means times. What is the opposite of times? Dividing. So instead of 5 times t, we're going to take both sides and divide by 5. That leaves me an answer of t equals 12. These are called one-step equations because it takes you one movement and the equation is done. The variable is alone. C is an example of where it was x minus 23. Well, what's the opposite of subtracting? Adding. So they're going to add 23 to both sides of the equation. The reason you have to do it to both sides is think of it as a balance. You've got this thing that's balanced right now. If I add 23 over to this side, it's going to be heavier on this side. So I need to add 23 to this side so that they're the same. And that leaves the x alone, and the answer is x equals 78. When it comes to this part of the problem, feel free to use your calculators. In part D, I had n plus 13 equals 43. What is the opposite of adding 13? Subtracting 13, which leaves me with n equals 30. These are all called linear equations. If you were to graph the first part of it, it would just be a line. There's no exponents. There's nothing weird happening. They are linear equations. All right, let's try a couple on our own. See if I have enough space to write here. I tend to write big. So one thing I like to do when I'm solving an equation is I drop a wall in. I put a wall where the equal sign is. I have a 19-year-old daughter who hates the wall, but I like the wall. So the reason I do the wall is so that I remember whatever I do to one side of the wall, I have to do to the other. So this one is a two-step equation. I have a 2 smashed up against the x, and then I have a minus 5. I'm trying to get everything away from the x. I want the x to be left all by itself. So I have a 5 that needs to move away and a 2 that needs to move away. The easiest thing and the correct thing to do is to move the 5 away first. How do I undo minus 5? What's the opposite of subtracting 5? Adding 5. I'm going to move this up a little bit so I can write a little better on the screen. I don't write well at the bottom. When I add 5 from to both sides, I'm left with 2x on the left side. What's 11 plus 5? 16. Take a moment. Your equation looks nicer. So take a breath, look away, and then come back and look at your new equation that's left. I have 2 smashed up against the x. That means 2 times x. What is the opposite of times? divide. So we're going to divide both sides by 2, which will leave me with my answer of x equals 8. It's a two-step equation. I had to add and subtract stuff first, then I had to divide by 2. You could plug it back in. You should plug it back in. 2 times 8 is 16, minus 5 is 11. There's definitely value in that. Now, I always get the question from people, well, wait a second, what about order of operations? You know, we always did multiplying and dividing first, and then adding and subtracting. Think about when you put on your socks and then your shoes. When you get home at the end of the day, which comes off first? Most people take their shoes off first, then their socks. So when you undo something, you do reverse the order of how it was done originally. So that's kind of why the order of operations looks backwards for people here. All right, let's draw our walls in for the next 2. Ooh, 7 looks ugly. So I have in number 6, b divided by 3 plus 8 equals 10. First thing I have to do is get rid of that plus 8. What's the opposite of adding 8? Subtracting 8 from both sides of the equal sign. Leaves me with b over 3 equals, and again, you can do 10 minus 8 in your calculator. It's 2. Now, I don't have anything smashed up against my variable, but I have b divided by 3. What's the opposite of dividing? Multiplying. So we're going to multiply both sides by 3, which leaves me with b equals 6. Again, you should plug it back in, make sure it works. That's still a two-step equation. It took me 2 solving steps and I was done. 7, we get into our longest, and this is absolutely as long as it can be. It's a 3-step equation. And not only is it a 3-step equation, I have to combine like terms first. I love when my highlighter doesn't work. There we go. That has a t in it, and that has a t in it, and they're on the same side of the equation. So I have to deal with that first. So the first thing I have to do is combine like terms. 4t minus 5t is negative 1t. I haven't done anything with the 6, and I haven't done anything with the right side yet. I do not generally count that as a solving step because it's just a simplifying step. Now, one thing you notice real quickly here is we've got t on both sides of the equation. So I definitely have to do something here. I can either move the negative 1t from the left to the right, or I can move the 3t from the right to the left. It really doesn't matter. I'm going to go ahead and move the negative 1t over just because it helps me not have a negative anymore. I'm going to move it by adding. That division step only happens once and it's at the end. I have negative 6 left here. 3t plus 1t is 4t plus 22. All right, it's looking better. Looks a little less ugly. Now I have to make everything that's with the t move away. So I have a 4 on the same side as the t, and I have a 22 on the same side as the t. I need to undo plus 22. What's the opposite of adding 22? Subtracting 22. And I'm going to come up here for some room. And you can do this part in your calculator. Put in negative 6 minus 22, you get negative 28 equals 4t. We're at my favorite step. I've always, for 30 years, I've called this the happy dance step, because when you see that number smashed up against the variable, you know you're ready to divide. That 4 is attached by multiplication, so we divide it. And again, use your calculator as much as you need to. For negative 28 divided by 4, it will spit out negative 7. All right, let's do one more. It's a little longer, and then we'll get into proportions. This one is probably a 3-step equation as well. I say probably because there's a chance something could cancel out, but I don't think so. I see z on both sides, so it's likely that it's going to be a 2-step. This one has a fair amount of simplifying I have to do first. I have parentheses. I can't solve anything with the parentheses in there. So the first thing I'm going to do is distribute the parentheses, or distribute the number outside the parentheses through the parentheses. Distribute means times. We did this earlier this semester, but it does mean times. 3 times z is 3z, minus 3 times 1 is 3. The 2z is still there, The 5z plus the 17 I haven't touched. I am still not ready to start solving because on the left side I have two different terms with z. So I'd like to combine those. 3z minus 2z. What is 3z minus 2z? It should be 1z. So on the left side I have 1z minus 3. On the right side I haven't done anything to it yet. I just keep writing it down. Everything's simplified. I'm ready to start solving. You can either move the 1z to the right side or the 5z to the left. My preference is to move the 1z because it's smaller. I like to always move the smaller number. Subtract 1z from both sides. As you get comfortable, you might do more than one moving in a step, but I'm not going to yet. The left side, I'm going to come up here. I have -3 is still there. Finally, I've changed the right side a little bit. 5z minus 1z is 4z plus 17. Aha, I'm down to a 2-step, yay. So the first step in working with a 3-step is turning it into a 2-step. Now I need everything with the z to go away. That z is like a magnet, repelling everybody, making it go away. There's a 4 that needs to go away and a 17. The first one to go away is the 17. How do you undo plus 17? Minus 17 from both sides of the wall. Again, do the left side on your calculator as needed. -20 equals 4z. I get really excited when I get to the step. This is my happy dance step. That 4 is smashed up against the z. I undo that. It's times. I undo times by dividing. And I get -5 equals z. Again, you can always plug it back in to check it. There's definitely value in doing that. All right. So that's 1-step, 2-step, and 3-step equations. It's as big as they will get. The next thing we're going to do, and kind of the last thing we're going to do, is this idea of proportions. When you have two ratios set equal to each other, or simpler, two fractions set equal to each other, they're called a proportion. One fraction equals another fraction. You can solve this by a method called cross multiplying. My youngest daughter, who's now 19, so she's not little anymore, learned these as butterfly problems. She learned that you do this thing when you do the cross multiplying, it looks like a butterfly wings. So I love that she learned it that way. The 100 times d is where the 100d came from. 360 times 35. And then you would end up dividing, but let's see, what does it tell me here? Why does it work? Yeah, they're talking about another way you could look at this. The d was divided by 360, so you could just multiply both sides by 360 to undo the division. All right. So this one is telling me I'm going to get 100d equals, I'm going to need to do 35 times 360 on my calculator, and I knew it was going to have gone to sleep. So 360 times 35, I get 12,600. And the cool thing is now all I've got is this little 1-step equation. That 100 is smashed up against the d. That means times. How do I undo times? I undo times by dividing. You can throw it in your calculator. The cool thing about dividing by hundreds is the zeros cancel out. So you could do it that way if you want to. D is 126. So let's do number 10 with the cross multiplying idea. So we'll do a different color just so there's not too much purple showing up here. We'll do pink. So make your butterfly wings to cross multiply. 36 times x is 36x. And then I have to do 12 times 15. 12 times 15. 180. And then, like I said, I love these because at this step, the 36 is smashed up against the x. That means times. I undo times by dividing, and I'm at my answer. Those are fun. And yes, I have an odd sense of fun. Let's take 180 divided by 36 in here. And you get 5. Purple box at the bottom of this page shows you the steps and how to do linear equations. So it goes, as opposed to proportions, it goes back to linear equations. It says simplify first. That means any distributive two. Step 2 is the adding and subtracting step. Move everything so variables are on one side, numbers are on the other. Step 3 is that happy dance step. It's usually division, it could be multiply, but if you have something smashed up against your variable, you're going to divide by that. So I think that's kind of fun. So they do give us 2 more worked out examples. I'm just going to hit the highlights of it because I don't want to bore you to tears, and it is all written out here. The first one's long. The first one, what they did first is they distributed through the parentheses. That's where the 10x minus 5 comes from. The next thing they did was combine 10x and minus 4x. That's how they got 6x. And then it's finally at this step where they're able to start solving the equation. They subtracted 1x from both sides, got 5x minus 5 equals 40, added 5, and then divided by 5. You'll notice in B, you could cross multiply or you could do it like equations. I like the cross multiplying method. Again, go back to your butterfly wings. 20x equals the 1,360 and then just divide by 20. Or you could do it was x divided by 80. The opposite of dividing is multiplying, so you could do it that way as well. So you'll get some more practice with this in your groups. And I appreciate your paying attention to this longer section. It's actually one of my favorite sections. And I will see you again next time. I hope you have a wonderful day.